now that we've covered some of the basic concepts of RLHF and we've taken a look at the data, we're finally ready to kick off that RLHF workflow and tune a large language model. To do all of this, we're going to be using Vertex AI, which is Google Cloud's machine learning platform. Let's get started. RLHF tuning jobs on Vertex AI run as Vertex AI pipelines. In machine learning, pipelines are portable and scalable machine learning workflows that are based on containers. Each step of your workflow, like preparing a data set, training a model, evaluating that model, these are all components in your pipeline. Now, as we've talked about, RLHF is made up of a lot of different steps. You've got more than one data set, you're training more than one model, and a pipeline turns out to be a convenient way of encapsulating all of these many steps into one single object to help you automate and reproduce your machine learning workflow. Now, I'm not going to spend too much time talking about pipelines here, since you don't need to write your own pipeline, you're just using an existing pipeline. But to make things a little more concrete, here is a basic machine learning pipeline. The orange boxes are components, or steps of your machine learning workflow. This is where some code is executed. The blue boxes are the artifacts produced by these components. By artifacts, I just mean anything that's created in a step of the machine learning workflow. So in this case, a data set and a trained model, and some metrics. So to run through this pipeline, the first thing we do is we execute this create dataset step. This results in a data set indicated by the dark blue box. And then this data set is used in the train model step, which outputs a trained model and some metrics that help us to evaluate how well that model performs. A reinforcement learning from human feedback pipeline is a little more complicated. It might look something like this. We first create a preference data set. That preference data set is used to train a reward model. The reward model is used with the prompt data set to tune the base large language model with reinforcement learning. And then we get a tuned large language model and some outputted training curves as well. In reality, the pipeline that we're going to execute has a lot more steps, but more on that shortly. The RLHF pipeline exists in the OSS Google Cloud Pipelines components library. So to run this pipeline, you'll first import it, then you'll compile it, and then execute it. So we'll need to make sure that we have a few different libraries installed. These are installed for you already, but if you are in your own environment, you'll run on pip install and then Google Cloud Pipeline Components. And you'll also need to make sure that you have the Kubeflow Pipelines library installed as well. So that is KFP. But these are already included in the environment for you right now. So the first thing that we're going to do is go ahead and import the pipeline from the Cloud Pipeline Components library. So note that right now this exists in preview. That's because RLHF is currently in preview, but eventually when it moves to GA, this will probably move out of the preview folder here. This pipeline has been written using the Kubeflow Pipelines OSS library. So the next thing we need to do is import the compiler from the KFP or Kubeflow Pipelines library. So we'll say from KFP import compiler. And if this seems a little confusing, don't worry, we're going to use all of these different elements in just a minute. So compiling a pipeline, what I mean by this is we're going to create a YAML file. So before we can create that YAML file, we're just going to define a name for the YAML file. So let's define the path to this file. We'll call it RLHF pipeline package path. And we're going to call this file RLHF pipeline.yaml. So once we've defined this, we can now execute the compile function. So this uses the compiler. This is what we imported from Kubeflow Pipelines up here. And then we call compiler and we call the compile function. So a whole lot of compiling here. But what we're really doing here is we're passing in two elements to this compile function. The first is RLHF pipeline, and that is the pipeline that we imported earlier from the Google Cloud Pipeline Components library. The next thing we pass in is the package path right here, which is the path to our YAML file. So if we execute this cell, what happens is compiling the pipeline creates a YAML file. So we can now take a look at this new YAML file that's been created. So I'm just going to take a look at the first few lines But if you wanted to look at the whole thing, you could, instead of saying head, you could say !cat, and that would show you everything in this file, but it's pretty long, so we're just gonna look at the very beginning. What you can see here is that this YAML file includes all of the information needed to execute a pipeline. It's basically a really long description in natural language of this pipeline. It's got a name, it's got a description of what it does, and then it's got all of these different inputs. So what does this pipeline actually look like? Well, Vertex AI provides you with a visualization tool where you can see all of the components of your pipeline. And this is what the RLHF pipeline that we're going to execute actually looks at. It's pretty difficult to see this all on one single slide here. There are a bunch of steps, and it probably just looks like a bunch of small boxes and lines connecting them. But we can zoom in on one specific part of the pipeline over here on the right. And if we do that, we'll see that this section looks a little bit like this. There are these boxes with these blue cubes on them, and these are components. Again, a component is where some code is executed. And then we have these other boxes with these yellow triangles, and these are the artifacts. This is anything that is created as a result of our pipeline. And if you look closely, you'll see that there's the word system artifact over here and the words component over here. So this might start to look a little bit familiar. There is this component that says reward model trainer. This is the step of our pipeline that trains the reward model. Underneath that, you can see a component called reinforcer, and this is the reinforcement learning loop that tunes the base large language model. You can also see that the reward model trainer component outputs some metrics, which are indicated here in this TensorBoard metrics artifact, and we will take a look at that in the next lesson. So again, this pipeline looks pretty complicated, but it's already been written for you. So even for your own projects, you won't be editing this RLHF pipeline component or the corresponding YAML file. The pipeline has already been authored by the Vertex team, and it's optimized for the platform and for RLHF, and the YAML file is something that's auto-generated, so you don't need to go in and edit anything in it, you just need to use it as is. So now that we have this YAML file, we can define a Vertex AI pipeline job, and I'll explain what all of that means in just a minute. But at a high level, this will take in the YAML file, and it will also take in all of the parameters that are specific to our use case. So let's take a look at the parameters that we're going to pass to this pipeline. The first thing I'm going to do is make a dictionary called parameter values. Now, there are a lot of different parameters that we're going to need, so we will take a look at them one by one. The first three parameters here are the paths to our preference dataset, our prompt dataset, and then also this evaluation dataset. So we didn't talk about the eval dataset in the previous lesson, but the Vertex AI RLHF pipeline allows you to pass in an optional evaluation dataset. What this means is that once tuning is complete, this evaluation data set will be used to perform a batch inference job where a bunch of completions will be created for a bunch of prompts. We will take a look at that in detail in the next lesson, but for now, all you need to know is that we have 3 data sets that we are passing into this pipeline. So in the previous lesson, when we took a look at these different data sets, we were just loading in small JSON-L files directly into memory. But for this actual pipeline, our data sets are much larger and they need to exist somewhere called Google Cloud Storage. Cloud storage is Google Cloud's object storage. That means that you can store images, CSV files, text files, save model artifacts, JSON-L files, just about anything. And you'll notice that these are Google Cloud Storage paths because they start with gs://. So anytime you see that, that means that this is a path to an object stored in Google Cloud Storage. Cloud Storage also has the concept of a bucket, and this is just what holds your data. Everything you store in Cloud Storage needs to be contained in a bucket, but within a bucket, you can create additional folders to help you organize your data. And then lastly, Vertex AI requires that all 3 of these data sets be in the JSON lines format. So if we look back at the notebook, you can see that for all 3 of these data sets, they start with this gs://, which again indicates that these are paths in Google Cloud Storage. And then they are all in this bucket called Vertex AI. This bucket has been created for you and it's a publicly accessible bucket. Within this bucket, there are additional folders for each of the different data sets. So for your own projects, you'll need to make sure that your 3 data sets are stored in a Google Cloud Storage bucket. And if you want some more details on how to do that, you can check out the optional lab at the end of this course, which will show you how to create a bucket and how to upload data there, as well as how to figure out what the specific path is that starts with gs://. For now, we can just use these data sets that I have uploaded for you already. The next parameter we're going to set is called large model reference. So in this case, we are going to set this to llama 27B. Large model reference specifies which large language model we want to tune. Again, in this case, we're using the open source llama 2 model, but there are other supported values as well, including TextBison and the T5X family of models. So as a reminder, there are 2 different models that get trained in this RLHF process. The reward model train steps sets the number of steps to use when training your reward model. The value to set here depends on the size of your preference data set. From experimentation, we found that the model ideally should train over the preference data set from around 20 to 30 epochs for best results. And then reinforcement learning train steps is the parameter that sets the number of reinforcement learning steps to perform when tuning the base model. This depends on the size of your prompt data set, and from experimentation, in this case, we found that the model should train over the prompt data set for around 10 to 20 epochs. Now, one thing to note is that I was giving these recommendations of how many epochs to train over these different data sets, but this parameter here takes in a number of steps. So if you need a handy heuristic to help you go from epochs to steps, I can show you that in the notebook. The first thing you'll do is set the size of your data set, and this could be for the preference data set or the prompt data set. So let's say, to make this a little bit easier to understand, let's say that our data set size is 128. Then we'll need to set the size of our batches. And again, this means, sending our data in batches instead of everything all at once. And reinforcement learning from human feedback on Vertex AI currently uses a fixed batch size of 64. So you'll need to set this number to be 64. You can't actually adjust the number of batches. But once we have both of these set, we can determine the steps per epoch by seeing how many batches it will take to complete our full data set of 128. So we'll import math, and that's so we can use a rounding function. And then we can say steps per epoch equals math.ceil, and this will just round up if these numbers don't divide evenly. We'll take our size of our data set and we will divide it by our batch size. And if we print this number, we'll see that that is 2, because 64 times 2 is 128. So it'll take 2 steps with the batch size of 64 to make it through our full data set of 128. Once we have our steps per epoch, we can then set the number of epochs that we want to train for. So let's say that we set this to 10. We can then determine the total number of training steps that we'll need by multiplying our steps per epoch by the number of epochs that we want to train for. And if we do that, and we print out the number, we'll see that this will be 2 times 10, so we'll need to train for a total of 20 steps. You can use this handy heuristic for your own use case. You'll just set the size of your preference data set or your prompt data set. You'll set a fixed batch size of 64, and then you'll set the number of epochs to train over, and you can use the guidelines that I mentioned earlier. So I'm going to go ahead and update the training steps here for both the reward model and the reinforcement learning loop to correspond to the size of my actual data sets here. So I'm actually not using the entire Reddit data set. It's a good best practice to execute the pipeline on a smaller subset of the data the first time around, just to make sure that the pipeline executes correctly. These pipelines run for many hours, so running them first on a small amount of data is just a useful thing to do. So in this case, my preference data set was size 3000, and the batch size is, of course, fixed at 64. So that helped me get my steps per epoch, and then I decided to train over 30 epochs. So once I had that, I knew that my number of training steps for the reward model was 1410. The size of my prompt data set was 2000, and the batch size is again fixed at 64. And this helped me to determine the steps per epoch, and I decided to train over 10 epochs for the reinforcement learning loop. And that is how I got to 320. So again, this is still a smaller amount of the full Reddit data set, but in the next lab, we'll take a look at results from training on all of the data. So the next three parameters are the learning rate multipliers and the KL coefficients. I would say that these are maybe a little bit more advanced of parameters and maybe not something you would set on your first try with this. You can set these to the default, but as you start really tuning the pipeline for your use case, you might want to adjust these a little bit. And I have the defaults set here already. That's 1 for both of the multipliers and 0.1 for the KL coefficient. The reward model learning rate multiplier and reinforcement learning rate multipliers are constants that you can use to adjust the base learning rate when either training the reward model or during the reinforcement learning loop. You can't actually adjust the learning rate itself, and that's because generally you want the learning rate to match the learning rate that was used to train the base large language model, and you might not know that off the top of your head. So the learning rate is fixed for you by the pipeline, but you can adjust these multipliers. So what that means is if you multiply by a number greater than 1, you're going to increase the magnitude of gradient updates applied at each training step. But if you multiply by a number less than 1, you'll decrease the magnitude of these updates. Next, we have the KL coefficient. This is a regularization term that helps to prevent something called reward hacking. So for example, let's say that our reward model tends to give higher rewards for completions that contain positive words like excellent, superb, great. During the reinforcement learning loop, our base large language model might learn that if it generates completions that are filled with positive terms but don't actually make a whole lot of sense, it will still result in higher rewards. So for example, our base large language model might start learning to produce completions that just have all of these positive words in it, like excellent, fantastic, awesome, great. And it doesn't really make a lot of sense to a human reading these responses, but the reward model is still giving high rewards. This is known as reward hacking, and the KL coefficient essentially helps to prevent reward hacking by preventing the model from diverging too far from the original model. So the tuned model essentially is penalized if it starts to diverge too far from its initial distribution and break the functionality of the original large language model. If you set this KL coefficient to 0, there's no penalty at all, and the larger you set this coefficient, the more the tuned model will be penalized for diverging from the original large language model. Okay, we are on to our final parameter, and this is the instruction, which I've set here to be summarize in less than 50 words. The instruction lets the model know what task it needs to perform. So this text is going to get prepended to each prompt in your dataset, both the preference and prompt datasets. So you only want to set this parameter if you don't already have the instruction included in your prompts. So if you recall in the previous lesson, when we took a look at the input text keys in our datasets, none of them had an instruction that said to summarize the text in less than 50 words. If we did include this instruction already in our dataset, we wouldn't need to set this instruction parameter. Because these base models have been trained over a large variety of different instructions, you can make this instruction parameter a simple and intuitive description of the task that you want the model to complete. But with that, we have wrapped up all of the parameter values that we need, and we are ready to actually execute this pipeline. So in this example, we are summarizing Reddit posts, but given the information that you have about RLHF, can you think of some other tasks and instructions that would be well suited to reinforcement learning from human feedback? For example, write a response to the following text. And in that case, your text that you might have could be the Reddit post. Now that we have all of our parameter values defined, we are ready to create a pipeline job. What this means is that this reinforcement learning from human feedback pipeline is going to execute on Vertex AI. So it's not going to run locally here in our notebook, but it's going to run on some server on Google Cloud. In order to do this, we first need to authenticate to Google Cloud and initialize the Vertex AI Python SDK. For this course, we've done that setup for you, but if you want to learn how to do this for yourself and your own projects, you can take a look at the optional lab included at the end of this course. So I'm importing an authenticate function that we have already written in this utils file. When I run this authenticate function, it's going to return the credentials, which is how we communicate with Vertex AI, and then the name of our project where all of these services are running, as well as the name of a bucket where we can store some generated artifacts from our pipeline. The last variable we'll need to set is the region, and this is the location of the data center where we're actually going to run this pipeline. Some services are only available in a certain set of regions, and this reinforcement learning from human feedback pipeline is available in this Europe West 4 region. So that's why I've set that here as this value. Next, we need to import and initialize the Vertex AI Python SDK. And if you're running this in your own environment, you will need to pip install Google Cloud AI Platform, but we have done that already in this environment here. So I'm just going to import that library now. And then once I've done that, we can initialize AI Platform. So we'll call the initialization function. And this is just something you need to do anytime you want to use this AI Platform SDK. So we'll set a couple of different variables here. We'll set the project ID, which we loaded earlier in the authenticate function. We'll set the location to be the Europe West 4 region that we just set in the previous cell. And then we will specify our credentials. And if we execute the cell, we would have initialized the Python SDK. So once we've done that, our second to last step here is to create our pipeline job. And so I'm going to call this job. And we'll call AI platform.pipeline job. And to this pipeline job, I'm going to pass in a few key parameters. So the first thing we'll pass in is a display name. And this is just any string name for what you want to call this pipeline job. So here I'm calling it tutorial RLHF tuning, but you could change this to be anything you like. After we've done that, we need to pass in a staging bucket. And so this is the pipeline route parameter. And basically what this means is that our RLHF pipeline is going to create a bunch of artifacts along the way. It's going to output some different files, and we just need some central location to store all of those things that are going to be created. So I'm just going to store all of that in a Google Cloud storage bucket that is saved in this variable staging bucket. Now we set the template path. And if you recall at the very beginning of this lesson, we created a YAML file. So if I print this, this is the path to our YAML file. And that was the YAML file that defined all of the information about our pipeline that we want to execute. And the very last parameter we'll pass in is parameter values. And this is that big dictionary we created up here of all of the parameters that were specific to our reinforcement learning from human feedback that were specific to our Reddit use case. So once we have defined all of these parameters here, we can create this job. And if we take a look at that, this creates this AI platform pipeline jobs object. And the very last step here is to run the job. And we do that by calling job.run. Now, this job is going to take several hours and it's going to require a lot of hardware. So for the purposes of this online classroom, you're not going to actually run this pipeline, but in the next lesson, you'll take a look at the results of a pipeline that's been executed already. So if you did want to run this in your own projects, what you would do is call job.run, and this will create and execute a pipeline for you. In the next lesson, we're going to take a look at the results of a pipeline that's already been executed for you. So these were some results run by my teammate Bethany, who ran an RLHF tuning job on the full giant Reddit dataset, and that job took over a day to finish running. So I'll see you in the next lesson where we'll take a look at the results.